Seriously not.
It's just saturated.
I said cyclohexene.
Sorry. Oh,
What did you do? Okay, I'm not happy with this because if I'm correcting your paper, I have no idea what you just tried to do. Okay, draw it properly, neatly. Okay, this is cyclohexane. I want cyclohexene. What's the difference? What's the difference between hexane and hexene?
Hexene.
I said hexene. E-N-E. Okay, this is what I want you to draw. Skeleton first. Do not draw hydrogens. That's the first mistake you made. Right? Because then you have to go back, correct it, that's all. Because hydrogens, what you do is make the carbons, draw the right number of bonds between the carbons, then you will clearly know how many hydrogens are required, right? This is right. This is cyclohexane. Okay? Were all of you able to find cyclohexane? Like do cyclohexane? Now make it cyclohexene.
That is
Now, if I tell you, actually, there's a little bit of a problem that I see with what grade 10 has to do because they don't tell you, when I tell you cyclohexene, I'm not telling you how many double bonds. So unless I mention, it means there's only one double bond. Okay? So if I was to make this cyclohexane, what I would do is I would remove this bond and give a, this is cyclohexene. But if I have 3 double bonds in a cyclohexene and they're alternating, that's when it becomes benzene. So that is the difference between benzene and cyclohexene. Usually when you properly name it, they're supposed to tell you this is cyclohexene. But say if I have 2 double bonds, I'm supposed to say cyclo, hexa. Okay, so this will be carbon 1, 2, 3. It'll be 1, 3, di-ene. This is how I would name this. Di means 2. So you have 2 enes, that means 2. And these numbers show that in what number carbon. So clearly this is in the alternate double bond. So cyclohexa 135 di-ene is what?
Hexa or hexene?
Here you say hexa, that's just a way of saying it. Even if I said hex 1,3 di-ene, it's still correct. Okay, it doesn't matter. So if I have cyclohexa 135 di-ene, now what is this molecule? What is this?
Cyclohex 135
Diene. Triene, yeah, triene. So if this is triene, then what is this compound? What is this compound? What is this? You know
Benzene.
This is benzene, exactly. So benzene is a common name for this one. You can go sit down. The only reason this name exists, this is the actual chemical name of this one. This is a common name because benzene became a very common molecule. Because I told you, anytime it has an alternate double bond, it becomes very stable and you use it for different purposes. So since benzene is something that we use a lot, that is why it has a common name. Okay? So this is how you come up with formulas. You can make it yourself. Okay, so hex means 6. What is pent?
5.
Okay, by now if you don't know meth, eth, prop all the way up till hex at least, then you have a problem. You need to fix it, okay? What do you call 4? Bute. Okay? Okay, right. So we're still in the physical side of this. So when you want to know if you have studied this chapter properly, you need to know, okay, do I know all the physical properties, these 3 points? Do I know how bonding works in carbon? Yes, I do. I can draw structures, I can name them. Now, the last part that's remaining in this is just functional groups. And once I get that down, I'm done with the physical side of it. This chapter is actually easy, if you properly understand it. Okay, so what are the 4 functional groups that you need to know? Okay. When you study it, study it in this order. Start from carboxylic acid. Carboxylic acid, ketone, and aldehyde comes in one category. Okay, I'll tell you why. This is just making it easy to study. You can follow a pattern. Alcohol. What else do you have? Okay, actually your textbook has given it the reverse of what I was saying. That works too. So I'll go by that. I'll go by your textbook. Alcohol. aldehyde, ketone.
Then carboxylic acid.
Okay? Yeah. And then obviously small. I'll just say 0 because these are all functional group that has carbon in it. Like it's carbon and oxygen. This one is just halogen, so I'm just going to put X. X means halogens. What group is the halogens? In the periodic table, where do halogens fall?
17.
18?
17.
17. 18 is?
No.
Yes. Okay, what's the valency of this one?
1.
What one?
Fluorine, fluorine, wrong.
Yes, minus. I asked valency. Okay? Okay, so what is alcohol? What is the chemical formula of alcohol? OH bonded to. So, okay. See, oxygen. What's the valency of oxygen? 2. So it will bond with 2 other things. One thing it's bonding with is oxygen that makes it hydroxide or the alcohol functional group itself, right? This oxygen is still not stable. It needs to bind with something more. So when this binds with a carbon skeleton, that's when it becomes alcohol. So how you write it is like this. This means this here, something else is going to come in. Okay? Now what is the other one? An aldehyde and ketone, the reason I put it together is, this is the functional group. You have whatever your carbon skeleton here, okay? Prop, bute, whatever. So that will form one, so what is the valency of carbon here? No, usually with carbon 4, right? So this carbon's already bonded with 2 bonds have already been formed with 1 oxygen. So this carbon needs to form bonds with something else. So this is called a carbonyl group, and carbonyl group is the functional group in an aldehyde or a ketone. And if these 2 things that it's binding, if on both sides it's binding to carbon, then it becomes a ketone. If one of the side is carbon and the other side is a hydrogen, that's when it becomes aldehyde. When you name this, you need to be very careful. If your carbon has 4 carbons and it adds to another, if say it's a butane. If a butane gets a functional group of an aldehyde, it will be butanol or pentanol. If a butane replaces a hydrogen to attach a carbonyl bond to it and become an aldehyde,
It will become propane.
no, it will become butanol. No, it will become pentanol. Why? Because the butane itself has 4 carbons and the carbonyl group has 1 carbon, so it becomes 5 carbons, which is why it is pentanol. Okay? And then if it's ketone, it's ONE instead of Al. Okay? And carboxylic acid, this is what so carboxylic acid is a mixture of this and this. So here, this is how it looks like. You can attach either. So if one is hydrogen, the other is carbon, it is 1 hydrogen and 1 carbon attached to a carbonyl group. What is it? Aldehyde. 2 carbons? Ketone. And carboxylic acid is a mixture of these 2. It's permanently in a OH group. And here a carbon skeleton can attach. Even this has an extra carbon. So aldehyde, ketone, carboxylic acid, you need to be very careful that it has an extra carbon from the carbonyl group. Alcohol does not have that. So now what's the homologous series?
It is a series of group of compounds which belong to the same functional group and have same chemical properties.
Okay, so
It is having a formula.
yes. Okay, this one is a homologous series.
B.
Okay, how many of you say A? Okay, you're looking around. So no one thinks it's A. Everyone's 100% sure that it's not A. Why?
Because it's one is functional group.
Ketone? Yeah, one is ketone, yes.
Then the one is
Aldehyde, exactly. So even though it has the same number of carbons, it's a different function. And will something in the same homologous series have the same number of carbons? No, the next one will have always 1 carbon extra because the difference is a CH2 unit, right? Propanol to butanol. Yeah. Or here I can also say heptanol. If it ends with the same suffix or prefix, that's when you know it's a homologous series, okay? Do you know how to name carbons properly, or do you want me to explain that too? So I'll ask you one question from your textbook, right? What are the two properties of carbon which lead to the huge number of carbon compounds we see around us?
Saturation and reduction.
Yes, that's all. What will be the formula and electron dot structure of cyclopentane? You already did cyclohexene, so you cannot do cyclopentane? You can. That's it, okay? Okay, then it's asking you to draw structures. Okay, can you do this exercise on page number 68? No textbook? Okay, I'll tell you. Draw the structures of the following compounds. 1, ethanoic acid. Okay?
Yeah. No, it's the
OH. There's one OH. Yep. Propentane. So draw pentane and replace one hydrogen and make it propane. What is this? Write it again. Write it again. No. Strike the everything and write it again. S10 means how many carbons? 2 carbons. How many carbons do you have? Okay, fix that. There and do that, okay? Because see, I can't really, if I do something like this and then H here, then I'm like, can you understand what this is? Don't do that, okay? Okay, name and structure of a saturated compound in which the carbon atoms are arranged in a ring. That's A. And B, use it. Okay. Give two properties of carbon. Okay, this one you don't answer again. This question will do. Write the name and structure of a saturated compound in which the carbon atoms are arranged in a ring. Is there cycloethane? No. Why?
Because
you cannot make a circle with 2 points, right? 2 points you can only make a line. You need more than 2 points to make a ring. So you can draw anything from cyclopropane all the way till any number of carbons.
From cyclopropane to?
No, you don't have to write everything. The question is write the name and structure of a saturated compound. So you only need to write one. But you can write cyclopropane, butane, cyclopentane, cyclohexane, anything. But the thing is, the number of carbons that you used and how you named it must be right. That's the only thing that's... So for alkanes or for saturated compounds, you have
CnH2n
plus 2. No one needs me to explain this, right? You know why. For alkene it is
CnH2n.
Yes. You know why the difference, right? As the number of bonds are increasing, the number of hydrogens will bonds between carbon is increasing, the number of hydrogen will decrease. That's why the hydrogen, so here it's plus 2, here it's plus 0, here it's minus 2. So that's the difference. But there's one more group that has only single bonds, but it has this formula. How is that possible? So if all the bonds between carbon...
That is cyclo.
Exactly. And you know what? So here, say if I make, this is CH3, H2, and how many? 3, right? So what is this? This is C3H8. So this is 3, 2n plus 2, so 6 plus 2, 8. That is what this is, right? If I want to make another bond between, so I'm going to do this. Right? So how do I make this cyclopropane? A bond needs to be formed between these two. And if I open it up, this is a single bond, okay? So all these are single bonds. So if I actually draw it out, what do I have? Right, this is what this is. But in order to make this bond, shouldn't these two hydrogens disappear? Otherwise, how is it that this carbon has 4 bonds? So what happens? It's still CnH2n. It's almost like this carbon formed a double bond between itself, but instead of this carbon forming a bond with the carbon next to it, it went and formed the bond with something on the other end, and that's how it became a ring. So in a ring, you can still have single bonds, but have this chemical formula. So you can have questions that say a compound X has general chemical formula of CnH2n, or it can give you C3H6. So when you see this, and the question will explain what happens when it reacts with something, right? And the question will be, what is X? So when you see this, you can immediately think that, oh, this is alkene. But you also need to keep in mind that it could also be an alkane with a ring. So it could be a cycloalkane or an alkene. That's one thing you might miss. Okay. So, do you answer the question?
Yes.
Okay, so the first half of the chapter is actually done. Okay, now let's go to the reactions.
Hydration.
Hydration? No hydration in this chapter.
Oxidation. No, oxidation.
Dehydrating.
Okay, that's dehydration is in the when you talk about ethanol and ethanoic acid separately. Okay, now let's just talk about chemical properties. I told you what's chemical means reactions. Okay. So what's the first one?
Combustion. Oxidation. Addition. Substitution.
Substitution. Okay.
Dehydrated.
Okay, I'm not going to explain that for now. I'll explain it when I explain ethanol and ethanoic acid. Okay. These are the four main reactions that you need to know like that. So combustion. What is combustion? Burning something, right? In the presence of oxygen. If I burn in the absence of oxygen, is it combustion? It's not combustion, okay? So when a carbon compound burns in oxygen, so anytime they say, okay, propane is combusted, means you know that the reaction starts with first write propane, whatever the what's the propane's molecular formula? CH3H. Propane. Yeah, CH. You can either write it like that or write it like this. It's up to you. Okay. So combustion. The moment it says it's burned in oxygen or combusted or whatever, the first thing you need to put is then. Anytime a carbon compound burns in oxygen, what are the two things you get? So you know how many carbons you will get? How many carbon dioxides? How many carbons will be there in the molecule? You will get that many carbon dioxide. So here you'll have 3 carbon dioxides, and you will always have 3 plus 1 water. That's an easy way to remember it. If you actually balance this out, this is what you will get. Because see here, you have 8 hydrogens, right? In a water molecule, you have 2 hydrogens. So if you have 8 hydrogens reacting, how many water molecules can form? Half of this, because 1 water molecules need 2. So if you have 8 hydrogens, how many water molecules will form? 4. So now what's the extra thing that's remaining? Oxygen. So how much ever oxygen is required for this, that much oxygen, because oxygen is freely present in the atmosphere. So this propane can use how much ever amount of oxygen it requires to burn. So how do I know how many oxygens? So this is 3 times 2, 6 oxygens, 6 plus 4.
10.
So it needs 10 oxygens. But one molecule has 2, so this is how you balance it. Okay? Yeah, that's basically it. So any molecule, now instead of 3, let's do, what will be here? 12. Right? What is this molecule? What's its name? Pentane. So if I'm burning pentane in oxygen, I'm not balancing. Oxygen is the last thing you balance, okay? How many carbon dioxide?
5 CO2.
How many water?
6
H2O. You can see why. See? 12 hydrogens, 6 H2O. Now
6 O2. 6 O2. 7 O2. 7 O2. 7. 8 O2. 7. It's 8.
Okay? So now say for instance if at all you're ever getting a number that's not even here. Say you're getting, instead of 16, when you added the oxygens, you're having 17 or 15 or whatever. But then what are you supposed to do? So you need to write the number, the half of this one, right? And you don't know what's, so either you can just write 8.5 or you can, instead of this, you can just write
7.5.
You can write 17 by 2.
7.5 also.
That's what I said. You can either write 7.5, or if you want, you can write this. Or what you can do is you can multiply everything with 2. So you can put a 2 here. If you multiply this with 2, you'll get a 17 here. This will become 10, and this will become 12. You can do any of the two, okay? Anything, it doesn't matter. But most of the times, when you use it like this, you will always get an even number. Because when you have one water molecule more than the carbon dioxide molecule, the oxygens will always add up in a way that you get an even number, so you won't have that problem. But you also have your first chapter for your exam, right? Reactions and balancing. So if at all something like that comes up, you need to use the half or multiply by 2. Both are right. Obviously, you will have 3 CO2, but how many water do you think you have? You only have 6, right? So here the number will be same. That's because the number of hydrogens went down. Because this rule is only for alkanes. This is for alkenes. Okay, but most of the time this is what you'll be asked. So just know this. Okay. So if it's unsaturated, this flame will be a little yellow and it will leave a little bit of soot, right? So tell me, you know that old, I don't know what to call it, the kerosene lamps that the flame is always blue. Why is it?
Because kerosene
It's a saturated. It's not because it's blue. Kerosene is not blue. Because see, this is a blue, it's a light blue. Have you not seen the flame? It has like the yellow-orange color on the sides, but the center, if you actually look at it, it's very blue, like light blue. Not a blackish blue, it's very, very blue. That's because it is a saturated hydrocarbon that's burning. Or there's another reason is, if combustion happens, you don't have, okay, you need 5 molecules of oxygen, right? Say for instance, this hydrocarbon is not getting this much oxygen, then what will happen? It will cause incomplete burning and combustion will not completely take place. Because of that, you can see these black soot getting deposited inside the bottle or the vessel or whatever you're using. That's why you can see in the old, when you use a vessel for a long time for cooking, if you can see black spots around it, that means that you're not getting enough oxygen. That means you need to make more air inlets. These days it doesn't really matter. This is more for olden days cooking. That's what it means when you have the soot deposit. We're using heat and light. And that's what we use as fuel. Burning of coal, petrol, everything. So that heat and light, that energy that they produce, that heat that's being produced, that's being converted to electrical energy, and that's how machines are running. That's why these are fuels. But the problem with these fuels is that when they burn, so fuel like coal, petroleum and all that, they have a lot of nitrogen and sulfur in it. So when nitrogen and sulfur react with, so here there's only carbon and hydrogen, so it's fine. Instead, say this compound has nitrogen. This nitrogen will join with oxygen to form NO2 and SO2 and other different types of nitrogen. These are pollutants and this is bad. That's why, and they cause incomplete burning. If complete burning happens, it's fine. But in all the cars that we use and everything, the problem is that the burning is incomplete. And you have these compounds being produced, which is bad for us. Okay? So all you need to know about combustion. Oxidation is pretty much the same. So when something gets combusted, it's also getting oxidized. Oxidation basically means adding oxygen or removing hydrogen.
Electrons.
Or electron. You learned acids and bases. So oxidation can mean 3 different things. Adding oxygen, removing hydrogen, or losing of electrons. So, but in carbon chemistry, mostly you can see the oxygen present. When you talk about inorganic chemistry, that's when you need to account for the electrons and everything. So here, so all combustion is oxidation, but not all oxidation is combustion. So for example, if you're removing hydrogen from something, that's not combustion. You're not burning anything, but you're still oxidizing it because you're removing hydrogen, right? So one main reaction, all you need to know is, if you have alcohol, and if you remove the oxygen from it, it will become, if you add oxygen to it, It will become
Carboxylic acid.
carboxylic acid. So actually what's happening is alcohol will get oxidized to aldehyde or ketone, but if the oxidizing agent is very strong, it cannot stop at that point. So alcohol will become a carbonyl carbon and will immediately change to form a carboxylic acid. And for that you need strong oxidizing agent. And what are the examples that you need to know? Potassium permanganate. What type of potassium permanganate? Alkaline potassium permanganate or acidified potassium dichromate, right? And you also need to heat it for the reaction to happen. Okay, now addition. So oxidation means plus O2 basically, or minus H2. For organic chemistry, this is all you need to care about. Okay, you don't have to worry about the electron transfer. For addition reaction, it means plus H2. Or you can also call it reduction, not for all reactions, but for most reactions, okay? So here what you're doing is you're adding hydrogen to whatever. So if you have a double bond and you add hydrogen, what will happen? Okay? So whatever is attached here, I don't care what's attached here. Yes, so now I'm adding, so say this is hydrogen, 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 hydrogen. And I'm adding 2 more hydrogens to this. So one hydrogen will go sit here, one hydrogen will go sit here, but in order for this to happen, so this becomes a saturated. So unsaturated, saturated. So mostly what happens is, so it's said that saturated fat is bad for us. Actually, okay, that's what our textbook says, and like the conventional thing is that saturated fat is bad. So for cooking, you need to use unsaturated fatty acids, right? But these days, okay, there are people saying that saturated fat to an extent is good for us and all that. But anyways, if I look at what the textbook says in the conventional way, saturated fat is bad for us, right? So this reaction is done back and forth to get, what we want. Because when I have a double bond, that's not good for me. So in order to sell that as a vegetable oil, I'm gonna hydrogenate it. So hydration, you were trying to say hydrogenation? Is that what you were trying to say at that time? I don't remember what you said. Okay. So when you hydrogenate something, hydrogenation is different from hydration. Hydrogenation means you're adding hydrogen, which is this. But hydration means you're adding water. Hydrating something. Okay? So, and this, when you're adding a hydrogen to this one, or hydrogenation always takes place in a metal catalyst. What's a catalyst? Yes, okay, I'm asking for a definition of catalyst. Catalyst is something that can speed up a reaction without actually taking part in the reaction. So if you use a catalyst before and after the reaction, the catalyst will remain the same. So all the catalyst does is it goes there, tells it to make it fast and leaves. Okay, that's what the catalyst does. So here the catalyst is metal, so it can be nickel, palladium or platinum, mainly nickel. Okay? And finally you have substitution. Substitutions, all you need to know is one gets replaced by the other. So here I have CH4, right? So how does CH4 look like? Right? If he was to draw, he would draw like that. Okay? And then you add chlorine to that. What's happening is one chlorine is going to replace one hydrogen, becomes Cl. So you have one more Cl remaining, and this hydrogen is also blue. So they join together and they become HCl. Right? So that's substitution. And for this reaction to happen, you need sunlight. Basically, for most of the reaction to happen, you need to supply some form of energy as heat or light or something like that. So, is alcohol a good solvent? Yes, it can dissolve any organic molecules. Also, it can dissolve in water, right? Why? I told you in the beginning. Hydrogen bonding, okay? It's polar. Yeah, basically that's all you need to know in terms of its physical properties. So always you take, if you're suppose drinking ethanol, you always need to take it as combined with something else, because even if you take a very small amount of pure ethanol, it can cause death. And that's what happens. You know, sometimes you hear news where some shops that sell alcohol where everyone just died altogether, like a tragedy that happens sometimes. That's sometimes because the ethanol is not mixed with what it needs to be mixed. So the quantity of ethanol that needed to be put in the alcohol was a little more than it should have been. And once that happens, we'll die. Okay, so ethanol, two main reactions that you need is it reacts with sodium. When it reacts with sodium, what is happening is substitution. So you write ethanol, right? So what happens is when I add sodium to this sodium is going to replace this one. Yes. Now there's a question that says, what else produces hydrogen while reacting with a metal? It's from other chapter. I'm asking you, some type of compound or something, when it reacts with metals, it will release hydrogen gas. Acid. Yes. So this works just like that, okay? So this is one reaction you need to know. Another reaction you need to know is if you put a very concentrated strong acid to this, what will happen?
Dehydration.
Dehydration. What is dehydration? I told you what hydration means. Hydration is adding water, removal of water. So from this, when I remove water, so I'll show you how this looks like actually. H, right? H, O, and H, right? So what is water? H2O. So this, and this gets removed. H2O. So now this carbon lost two bonds, right? 1, 2. So what is it going to become? So in order to
CH2 double bond CH2.
Yes, so what will happen is actually, this is not what's happening. The OH is lost from this carbon, the hydrogen is lost from this one. So this is how the, because one carbon cannot lose everything. So what will happen is this carbon is lacking one bond, this carbon is also lacking one bond. So they'll just form a bond. So this has two hydrogens, this one also has two hydrogens, right? H2 and CH2. But they need two more bonds. Already one bond is existing, this one, and a new one is formed, and then what did you remove? H2. So if you have 3 molecules of this one, you will have 3 molecules of water formed. So what is the dehydrating agent?
H2SO4.
Concentrated H2SO4. Dilute H2SO4 cannot do this. Okay? Now, what does acidified KMnO4 do? Alkaline KMnO4, what does it do? Oxidizes. So it turns, so if I add oxidize, so basically you need to know 3 reactions of ethanol. One is dehydration, the other one is oxidation. So to ethanol, if I had acidified potassium dichromate, what will it give me? Carboxylic acid. So ethanol will give me ethanoic acid, right? Propanol will give me propanoic acid. Ethanol on dehydration will give me ethene. So you need to know which one gives which. And obviously sodium will give you ethanoic or propanoic or whatever. So obviously it's an acid. So what is the common name? Acetic acid. But if I have a little amount of acetic acid put in water, what is it? Vinegar. So obviously you know it has that salty taste, like a tangy taste. And then, is this an organic acid or a normal acid? So H2SO4 can split into H plus and SO4 2 minus, right? Does carboxylic acid actually do that? No, because it's a weak acid. It doesn't completely dissociate on putting it in water. And the main reaction you need to know here is esterification. What is an ester?
Carboxylic acid. COO.
Yes.
Ethanol and ethanoic acid.
Ethanol and ethanoic acid. So when an alcohol and an acid together will give you ester. So ester is basically, it's the same thing. See, this is carboxylic acid, right? So instead of this, so this is attached to some C something. So instead of this H, if I replace the H by another C something, that is an ester. So ester is basically, you know how aldehyde is the end and the ketone CO will be in the middle? You know what I'm talking about, right? In aldehyde, CHO is in the end and CO is in the middle. Exactly like that, in carboxylic acid, you have COOH in the end, but if that COO comes in the middle, you have an ester. So you need to know properties and all that. I'm not explaining all that. So and so the formation of this is an esterification. So if the ester has like, okay, 2 carbons here and 3 carbons here, you can easily say that the bond formed, this one will be 3 carbon acid, which is propanoic acid. You have a 2 carbon alcohol. So in order to give a 5 carbon ester, where the 3rd carbon is your carboxylic acid group, then you will have a 3 carbon acid with a 2 carbon ethanol. So a question can be that, name the alcohol and the acid that formed this ester. So you need to be able to explain that. Okay? Reaction. So this is an acid, right? What is the normal thing that an acid reacts with? Base. Acid and base react to give salt and water. So what's the salt here? So actually, with sodium hydroxide, 2 things can happen. When an ester reacts with sodium hydroxide, you get alcohol. But when ethanoic acid reacts with NaOH, NaOH is a base, what will you get? Salt. And what is the salt? This is the salt. Okay? Salt plus water. And this is all you need to know. And, oh wait, there's one more reaction. Carbonates and hydrogen carbonates. It's just the same. Because for everything you will get salt. Because hydrogen carbonates, normal carbonates, hydroxides of metals, these are all bases. So anytime a base reacts with an acid, you always get salt and water. So this is the salt you will get, and then H2O will be there. And since carbonates and bicarbonates also have an extra carbon, you'll also get CO2. That's the only difference. And the number will vary according to your balancing. Dirt. Why are we using soap? To clean dirt, right? So, say this is a piece of cloth, a fabric, any fabric, okay? And you have some sort of dirt sticking on it. Now, so what exactly is a soap? Soap is an organic molecule. Okay, so say soap is a big chain of a fatty acid. Okay, what does an acid in the end have? COOH. And this is a long chain. This is C. It's a big chain. Okay, and so many molecules of this put together is what makes up soap. Because we already said that in saponification reaction and all that, right? So we know that they're organic molecules. So this part is just carbon and hydrogen, It's completely covalent bond. This part cannot dissolve in water because water is polar, this is non-polar. So something that doesn't like water, we call it hydrophobic. Now this part can form hydrogen bonds with water. So this part can interact with water. So this is hydrophilic. So if I was to put all the molecules of soap together, this is what I'm just going to put, this is the hydrophilic part, this is the hydrophobic part. Okay? So now if I put these 2 molecules in something that has water, what happens? So this is hydrophilic, and that contains water. What will happen is, this part will try to face water, this part will try to stay away from water. So say this is a cup with water, right? So when I put this in, what will happen is, this part will touch water, this part will touch water, and this one will try to stay like this. They're trying to stay away from water. But here, obviously, this is going to touch. So say I have more molecules, what they will do is they'll do this. And they just form the circle. So when they form like a unit, what happens is this hydrophilic part is going to protect this hydrophobic core from touching water. This is how soap molecules work. And this thing is called a micelle, or a micelle, however you want to say it. So what happens is the detergent or the soap will go near the dirt molecules and start forming this thing. So obviously what will happen? And it will go near the dirt. Why? Because the dirt is not water. It can react with the dirt molecule. It cannot react with water. So it's going away from dirt. So obviously if something is pushing it from all corners, so okay, say this is a dirt molecule, the soap molecule will come like this and push it and take it away. So along with one soap, like a chunk, you get the dirt out. And sometimes, some stains that you can't remove, you soak it in water for a long time and it goes away because you're giving more time for this to happen. Okay? That's basically it. And now the only small thing you need to know after this is what makes the water hard and what makes the water soft. So water obviously it's not pure water. It also has other salts and minerals and all that. So if you have sodium or potassium salts in it, it will be soft. Instead of sodium and potassium, if you have calcium or magnesium, it will be hard. And normal soap molecules cannot do this. If calcium and magnesium is present, it will block it. So that's why you use detergents. That's why detergents are hard. So you don't use your normal, everyday clothes with detergents. You use milder soap instead. Because you don't have that much dirt, but if you're using something that you really use to clean, like stains and something that's really, not mild, then you need to use detergents. And that's why in hard water, our normal soap will not foam. Instead, in hard water, if you use proper detergents, then it will foam up. And that thing that forms in a hard water, if you try to put regular soap, that's called scums. Well, that's the chapter. Do you have any questions from this chapter? No questions? Everything? No, so are you sure that if I ask any questions, you get 100 now? No? An 80 at least from this chapter? No? Wait. Huh? I am giving you a break. Okay, so do one thing. Go home today and study this chapter. Do you have any tests, exams, or anything coming up right now? So go home today, 100% finish this chapter. Okay, and if you have questions, ask me tomorrow. I'll come tomorrow. Okay? By the time I leave, I want you to know this chapter properly. Okay? And once that's done, use the same strategy that you use to learn this chapter for other chapters. And this is one of the hardest chapters. If you get this out of the way, then the rest will be